Hi everyone, this is the Mathemagic Channel. Today we are covering the IGCSE Math Edexcel Paper 3H in our Perfect Paper series. This is a complete walkthrough. The paper is from May 2017. You can find the paper in the description below, so make sure you try the paper first and then look at the solution with us afterwards. It'll save you a bunch of stress, so without further ado, let's jump right in. Starting with the first question here, 10a plus 25, we can see that 10 contains a 5 and 25 contains a 5 as well. So we can say that this is 5 times 2a plus 5. For question B, factorizing 7w minus 4w, the 7 and the 4 have no common factors, but w is a common factor to both. So we can say that this is w times 7w minus 4. And for this question here, expand p squared times p minus 5. P squared times p is going to be p to the power 3 and minus 5p to the power 2. Expand and simplify. For this question, we're going to need to use our FOIL technique where we do x times x times 7, negative 3 times x, and negative 3 times 7. Following the steps here, x times x is going to give us x squared. X times 7 is going to give us 7x. Negative 3 times x is going to give us negative 3x. And negative 3 times 7 is going to give us negative 21. So the answer to this question is x squared plus 7x minus 3x, so plus 4x minus 21. And we get 2 marks for that. And here for question G, f cubed minus 7f when f is equal to 2. So what we can say here is 2 cubed minus 7 times 2, and 2 cubed is 8, and 7 times 2 is 14. So this will be 8 minus 14, which is negative 6. So well done for doing these questions. Moving on to question 2, this looks like a transformation type of question. And we have a shape, which is an L shape, and is called P here. And we're asked to enlarge the shape with scale factor 2 and center 7, 3. So notice that the center is given to you here. It's marked with an X. And so the center, which is at 7 on the X-axis, is 4 away from the right corner of your shape. So your new right corner should be 8 away from this point here. So 7 minus 8 is going to bring you to negative 1. And this will be your new right corner. Now your left corner from 7 to 1 is actually 6 away. So your left corner will need to be 6 times 2, which is 12 away from 7. So that's going to bring us to negative 5 here. And actually we probably have enough information right now to just draw the shape and enlarge it. So as you can see here, I've drawn the shape and multiplied all the lengths by 2. So the length on the left hand side was 3, and I've doubled it to make it 6. And following this L pattern, so just using the base here, we can label the new shape Q, and this is an enlarged shape by a factor of 2. So rotating the shape around the point P, clockwise will be going down this way, and anti-clockwise will be going this way. So we need to make sure that we rotate the shape P in this area of our diagram, and 90 degrees is a right angle. So making sure that we draw a right angle, and we could probably start with the first corner, and once we've placed the first corner, it should be relatively easy to map the whole shape. So drawing a right angle and noticing that the first corner was 1, 2, 3, 4 away from our point 7, 3, the first corner will be 1, 2, 3, 4 away down here from the same point. And so I'm going to go ahead and draw that. So we've drawn this shape and we've made sure to rotate it so that it's now lying down sideways and it's been rotated anti-clockwise. And we need to label this shape and call it R, and this will give us 4 marks on this question. On to question number 3, and this calls for a recipe for 4 people. And we notice that most of these numbers are divisible by 4. So the first question says we want to make an apple and blackberry crumble for 10 people. Well, how do we go from 4 to 10? Well, if you do 4 times 2.5, you'll get to 10. Or if you do 4 times 5 over 2, which is the same as 2.5, you'll get to 10 as well. So you can use this as a ratio or a scale factor. And if you weren't sure about how we got 2.5 or 5 over 2, you can simply do 10 divided by 4, and that will give you 2.5. So when you see the number of apples here, 300, we could do 300 times 2.5 or 5 over 2. I prefer to do 5 over 2 because 300 divided by 2 will give me 150, and 150 multiplied by 5 is kind of the same as 15 times 5, which is 75. So this will be 750, and this is good here for us to move quickly and do the work without stressing out too much. In the next part of the question, we have 920 grams of blackberries, and we're trying to see how many people that will accommodate. Well, perhaps you can use a calculator here, and by doing 920 divided by 115, you'll find out how many apple and blackberry crumbles you can make. Now remember, each one of them is good for 4 people, so that'll be the number of blackberry crumbles, but not the number of people. So we can go ahead and do that. 920 divided by 115, that is good for 8 apple and blackberry crumbles. Now remember, each one of them accommodates for 4 people, so we can multiply this result by 4, and we get 32 people. So the answer to this part of the question will be 32 people. In question here 4, we're given the length of 40 leaves in centimeters, and so some leaves are between 0 and 1 cm, 5 leaves are between 1 and 2, 11 leaves are between 2 and 3, and the first question is, write down the modal class. Now mode is the number repeated the most, and we see that with a frequency of 14, the class 3 to 4 centimeters is repeated the most. So this will be the modal class. So 3 smaller than L, smaller than equal to 14. In the next part, we have to find the mean length of the 40 leaves. Mean is average, and so the average of these 40 leaves put together is going to be an estimate of the midpoint of each interval. We can't do much better than thinking about the midpoint from 0 to 1, as we don't know whether those 4 leaves are closer to 0 or closer to 1. So what we need to do here is to do 0.5 times 4, which is going to give us 2. And then here we can take the midpoint, which is 1.5, and multiply that by 5, and that's going to give us 7.5 centimeters. And so the next one we can do here 2.5 times 11. Now multiplying by 11 is pretty cool because there's a shortcut technique where you can say 2 plus 5 is 7, so you can say that this is 275, and since we have 1 decimal point we can put it here. So 2 plus 5 is 7, and we put that number in the middle. That's a shortcut technique for multiplication by 11. For the next one we can do 3.5 times 14. 3 times 14 is 42. Half of 14 is 7, so this will be 49. And for our last one here, we can say 4.5 times 6. 4 times 6 is 24, and then half of 6 is 3, so this will give us 27. Of course, you can do all of this with a calculator. And so to find the mean, we can add all of these numbers together. So we can say 2 plus 7.5 plus 27.5 plus 49 plus 27, and that result is going to be 113, and we divide that result by 40 because we have 40 leaves. So divided by 40 gives us an average length of 2.825. Now 2.825 needs to be rounded to 1 decimal place, so 2.825. Oh, 2.8 should be a good estimate then. For my next section, I need to add these numbers together and perform that division and add 2.2 squared. So 7.3 plus 2.1, that is going to be 9.4. So I can do this without using my calculator, although you can absolutely do that. And 2.2 squared with or without a calculator is 4.84. Now knowing your squares is a little bit helpful here. And now I can go ahead and use my calculator. So I'm going to type in 9.4 divided by 6.4 plus 4.84. So that result plus 4.84 is 6.30875. And it says here that I should write down all the figures on my calculator display. So I'll just write 6.30875. 6.30875. And rounding this to 3 significant figures, so 3 numbers which mean something. So the 6 is significant, the 3 is significant, and the 0 is also significant, but it should be closer to a 1 than to a 0. So we're going to say 6.31 here because the number after 0 is an 8, and this will be good for 3 significant figures. In question number 6, we have to graph y equals 2x plus 4 for values of x from -3 to 3. And it's worth noting here that the actual window that we're given goes from -3 to 3. Now there are 2 ways mostly you could do this. The first way is to understand that this is a line, a straight line with a gradient of 2 and a y-intercept of 4. The second way would be to plug in a couple of points, and a couple of points will be good enough for you to draw a line. So let's do both ways so that you're pretty comfortable with all of this. When x is equal to 0, y is equal to 4 here, 2 times 0 plus 4. When x is equal to 1, y will be equal to 2 times 1 plus 4, which is 6. So we can do that. Starting from the bottom side of our graph all the way through to the top here. So I've drawn a line on our graph here, which as you can see goes through this point, which is 0, 4, and also the point 1, 6. Now this line does indeed go up by 2 when it goes across by 1. If you look at this using a little staircase method, we go from 6 to 8 and then we go across by 1. We go from 8 to 10 and then we go across by 1. And make sure that your graph starts at -3 and finishes at +3. So this will be good for 3 marks. Now let's move on to question 7. And in question 7 here, we have to find the length of AC. And so to find the length of AC, this is a right angle triangle. We will need to use right angle trigonometry. The ratio which we need to use for the adjacent side to the angle and the hypotenuse is the cosine ratio. So we can say cosine, and we always say cosine of an angle, so cosine of 22 degrees is equal to the adjacent side, which is 14.9, divided by the hypotenuse, which in this case is the length AC. Okay, so moving AC to the left here, we can say AC cosine 22 is equal to 14.9. And for our final step, we can say AC is equal to 14.9 divided by cosine 22. Using our calculator, now be careful, if you use a phone calculator, you will type 22 and cosine. It'll give you the cosine immediately, so you probably want to do that first. The calculator I'm using for this video has a similar format. So I'm just going to type 22 here and the cosine key, and this will give me the cosine of 22, which is 0.9271. And so I can simply say, okay, 0.9271, 14.9 divided by 0.9271, which is going to give me 16.07. And to 3 significant figures, the 1 is significant, the 6 is significant, and the 0 will round up to a 1. So the answer to this question will be 16.1. So we can go ahead and write 16.1 in centimeters here and move on to the next question. In this next question here, we have to try and understand the percentage increase in Donald's pay from 2014 to 2015. His increase in pay here is 668.8 minus 640. And so for the amount of money that he earned, that's a little bit extra here, it is $28.8. Now when you work out a percentage increase, you should take that amount of money and divide it by the original amount. So as we can see here, 28.8 divided by 640 is 0.045, which as a percentage, we can multiply by 100, will be 4.5%. And for this question, that is what we need. So we're just going to go ahead and say 4.5% here. In the next section, in 2015, Donald's weekly pay was 95% of his pay in 2016. So his pay in 2016, we can call that P. And P times 0.95, that's the amount of money that he was getting paid in 2015. And that amount of money is 668.8. So 668.8. And so what we can do here is move the 0.95 to the right, so times becomes divide. P equals 668.8 divided by 0.95. And using our calculator again, as we can see here, this is 704. And so we can go ahead and write $704 here, which makes sense. It's a larger amount of money that he's getting paid in 2016 than. In question 9, we're requested to find a bisector of the angle PQR. Now, a bisector is something which cuts the angle PQR in half, so it halves the angle. Using a compass, we can try and find a random length, and poking at Q, we should be able to make an indentation here on the line QP. And poking at Q again, we make a similar indentation on the line QR. So those two indentations are of equal length. And using the same lengths again, we can make a further indentation here using our first indent between Q and P. And using our second indent from Q to R, we can make a second indentation here, which is going to cross this third one which we made here. And so now these two little indentations are crossing each other, and we're able to use that to draw a line straight through. The reason why this works is because this line is actually the diagonal of a rhombus. And so I've drawn in black here these extra two lengths which would connect to the point. Now you don't need to do this for this exercise, but it's purely to demonstrate to you that these four lengths would be the same. And in doing that with a compass, what you've achieved is you've drawn one of the two diagonals of a rhombus. And the diagonals in a rhombus meet in the middle at a right angle, and they also bisect the angles, which is what we need for this question. So we're using the properties of diagonals of rhombuses here. And let's move on to the next question. In this next question, we have to solve a set of simultaneous equations. So I would encourage you to label your equations 1 and 2 perhaps. And you have some choices here. You could maybe multiply the first line by 5 and the second line by 2, which would make the x's 10, and you could subtract one line from the other. Well, that seems like a good strategy, so let's go ahead and do that. So we'll multiply the first line by 5, so 10x, and 7y will become 35y, and 31 times 5 will be 155, so make sure to multiply both sides of your equation. And for your second equation, you can multiply everybody by 2, so you get 10x minus 6y equal 32. You may label your lines again, and here you have a choice between doing line 1 minus line 2 or line 2 minus line 1. I would encourage you to do line 1 minus line 2, and the reason for that is to keep your variable positive, the variable being y. If you do 35y minus 6y, you'll get 41y. Which is much better than if you did line 2 minus line 1, and you get minus 6y minus 35y, which is negative 41y. As much as you can, you'd like to keep the variables positive. So let's go ahead and do 35y minus 6y, that is 41y, and 155 minus 32, which is going to give you 123. And as I move the 41 to the right, we can do 123 divided by 41, and that is 3. Now we have the y value. It'd be great if we could find the x value. In order to do that, you could plug the value 3 back into one of the original equations. Perhaps we can plug it back into equation number 1. So 2x plus 7 times 3 is equal to 31. 7 times 3 is 21, so 2x plus 21 equals 31. 2x is equal to 31 minus 21, which is 10, and we finish with x equal 5. So x is equal to 5, y is equal to 3. In this next question, we have to find the probability in part A that an adult's age is more than 50 years. And so you have a bunch of ages here in intervals. And we can see here that 50 to 60 includes 16 people, but also 60 to 70 is 8 people, and 70 to 80 is 4 people. So if we add these three together, 16 plus 8 is 24. 24 plus 4 is 28. So there are 28 people who are older than 50 years old. Now the probability of someone being older than 50 years old, you could say, is 28 out of the total number of people, which is 90. And we can go ahead and plug that into our calculator. And as you can see here, 28 over 90 is 0.31 with the one recurring, 0.31 with a recurring one. Now you're not requested to round this to any certain specific decimal value. So I would suggest you just keep it at 0.31 with the one recurring, or you could even keep it as a fraction. You could simplify 28 over 90 to 14 over 45, most likely. The next section is a cumulative frequency table for the 90 adults. And we need to state how many adults are between 20 to 30 years old. Well, we know that that's 4. And how many are between 20 and 40 years old? Well, that'll be the first 2 rows together. So 4 plus 28, which is going to be 32. And how many are between 20 and 50? Well, 32 plus 30, which is 62. And how many are between 20 and 60? Well, we can add an extra 16 here, so this will be 78. And for the next section, 20 to 70, we can add another 8 here, which will bring us up to 86. And if we've done our work properly, we have an extra 4 at the bottom, which will give us the whole population, which is 90. So for part C, we're asked to produce a cumulative frequency graph for our table. And so we always start a cumulative frequency graph at 0. This is quite important. And I've marked the numbers down as 4, 32, 62, 78, 86, and 90. And it is very important that you would mark the 4 on the right-hand side of the interval. So we can see here that we're going from 0 to 10, so we're moving in intervals of 2. You can separate 0 to 10 into 5 sections. So each step up represents 2. So as I'd like to put the 4 here, I'm just going to put it two indentations up. And 40 will be 32. So I'm going to go ahead and go just above 40 by 1 indentation here. And for my next one, which will be 62, I go to 50, and just above 60 here, this will be 62. And for my next one, which is 78, I go to 60, and just before the 80, 1 indent down, I'll find 78. And 70 will be 86. We can see the graph is tapering off a little bit here. I go ahead and make a dot at 86. And the last one, 80, should be at 90 exactly. And this looks quite a lot like a cumulative frequency graph. Now, as you go ahead with these, you can use a ruler, but you can also freehand these kind of graphs so that they look a little bit more sightly. You can go ahead and do that. Now, it doesn't have to be perfect. It has to be reasonable. So I would just encourage you to, with your pencil, connect the dots as well as you can. And this is pretty reasonable. In this next section, it says all of these adults with an age greater than 65 years old receive a discount on the shopping bill. Use your graph to find an estimate for the number of these adults who receive a discount. So 65 will be between 60 and 70. So we can draw a straight line here to try and see where we meet our graph. And it seems like we meet the graph around 82. And just to confirm this, we're going to draw a line from 82 to the graph. And so if we think about the number of people we have between 82 and 90, so the people who are older than 65, there'll be 8 people. 8 people who are older than 65 years old and who will receive a discount. Of course, this is an estimate. It's not an exact number, but it's as good as we can do with this graph. Moving on to question 12 here. 0.000451 in standard form. And so this is in the 10,000s here. There are 4 zeros before the number. So we can say 4.51 times 10 to the negative 4. In part B, 7.8 over 2.4 times 10 to the 5 over 10 to the negative 4. So we can say that this is 7.8 divided by 2.4. And we can use the rule of exponents here and simply state that this will be 10 to the power 5 minus 4, which is 10 to the power 5 plus 4, which is 10 to the 9. So we're now talking in billions. Using our calculator, 7.8 divided by 2.4 is 3.25. And so the answer here is 3.25 times 10 to the power 9. On to question 13. 13 shows you two mathematically similar cups, A and B, which means that all the lengths, all the angles, so the angles are the same, but the lengths are scaled up. And in this case, we can see that we've gone from 12 to 8. So what can we do with 12 divided by 8? Well, 12 divided by 8 here is the same as, if I divide top and bottom by 2, it's the same as 3 over 2, which is 1.5. So 1.5 is what we call a scale factor here. So I can go ahead and say this is a scale factor. So if the scale factor is 1.5, I can go from the small cup to the big cup by multiplying by 1.5, or I can go from the big cup to the small cup dividing by 1.5. So we can go and find D here by saying that 9 divided by 1.5 is going to be equal to 6, and 6 is equal to D. So we can say D is equal to 6 centimeters. The volume of B is 160 milliliters. Work out the volume of A. It's important to note here that if the scale factor is equal to 1.5, the area factor will be equal to 1.5 squared, and the volume factor is equal to 1.5 cubed. And here we will need the volume factor because we have the volume of B and we're looking for the volume of A. And 1.5 cubed, the volume factor is 3.375. So the volume factor is 3.375, which means the volume of A is 3.375 times more than the volume of B. And 160 times 3.375 is 540 milliliters, and that'll be the answer to this section. So we can say VA is 160 times 3.375, which is equal to 540 milliliters. In this section, we have two solid plates, P and Q, which are mathematically similar and made of the same material. So we're given two surface areas, P and Q, and in question C, we have to find an expression for the weight of Q in terms of PQ and the weight of P. So it's important here to understand we're trying to go from P to Q, otherwise we won't be able to answer part C. So we're going to say that P times some area factor is going to be equal to Q, and therefore we can say that the area factor is Q divided by P. And so if an area factor is Q over P, a scale factor is going to be the square root of Q divided by P. Now this is a relationship that allows you to go from Q to P. Now it's important to note that this scale factor allows you to go from P to Q. And furthermore, the volume factor allowing us to go from P to Q is going to be the square root of Q over P to the power 3, as the volume factor is the cube of the scale factor. So this question is a little bit dicey because we needed to first square root the area factor and then cube it to realize that that's the volume factor. Now, if the weight of Q has a relationship with the weight of P, so the weight of Q is going to be equal to the weight of P times a volume factor. And so this question was definitely a little bit tricky, but we can say that the weight of Q is equal to the weight of P times the square root of Q over P, and all of that will be to the power 3, since it's the weight of P multiplied by the volume factor. Now this is the end of part 1. Meet us again in part 2 for the completion of this paper in our Perfect Paper series. See you in the next one.